And in today's session, we will talk about KMS in depth. We will start off with understanding the value of security. What is KMS and why is it so important? What is the difference between symmetric and asymmetric keys? What is custom or master key? What are data keys and what are data key pairs? How do data key or data key pair signing and verification work? And we'll also discuss about envelope encryption. And we'll also talk about what is CMK Rotation Policy, how to rotate CMKs automatically and manually, and we'll also try to understand server-side encryption of S3 using KMS, SSE-S3, SSE-KMS and SSE-C. And we'll also understand the client-side encryption for S3, how does encryption and decryption work on the client side. And finally, we'll do a small hands-on demo for AWS KMS, and all the timelines are in the description below. So if you want to skip to a particular section or if you want to rewatch it, please check that out. So this is going to be a very long session, but it'll be a really helpful one. So please make sure you grab a cup of coffee or tea or any energy drink that you prefer to keep you going. So I hope you're excited. Let's begin. But before starting anything, I want to talk about encryption, and when it comes to security, what does it bring to the table? So let's suppose you're working with your team and you want to send a message to one of your teammate Daisy. So you give the message to John and the message was, "Good morning, the meeting is at 2 p.m. That's your message. And John, being unfaithful, the person he is, he delivers the message as, "Hey Daisy, the message that you have received is, good morning, the meeting is at 4 p.m. And this is what Daisy received, and because of which she actually missed the meeting. So what did we learn here? When it comes to your data, never trust anyone. To avoid the information being manipulated again, what you did was you encrypted the message and you gave the encrypted message to John to deliver it to Daisy. And how did we do that? So the message was encrypted using a common key which I had given, or which you had already given to Daisy as well, using which she will be able to see the message by decrypting it using the key that we have shared. So that will be a common secure key. And the middleman here will not be able to understand anything. He'll not be able to read the message. So what did you understand here? No, I'm not asking you to tell me that you will be using WhatsApp to send the messages. I get that. Imagine this as a hypothetical scenario. I know it. So we got an understanding that to protect our data, we need to ensure it has a layer that encapsulates it, which masks the actual data inside it. That's what encryption is in simple terms. When we think of the definition, encryption is a process of encoding information. So you're changing the data in one form to another using a set of rules which makes up as encoding. So this process converts the original representation of the information, known as the plain text, into an alternative form known as the ciphertext. And this is what we will be sharing to Daisy so that she can use the common secure key to decrypt that and read the message that is stored inside the plain text. And the middleman that you have here will have no clue about what the information actually is. And that is how encryption actually works. So this is the encrypted message which is being sent to the user, and the message is being encrypted or decrypted using the key and thus being read as well. So in normal encryption, you take the plain text that you have here, you encrypt it using a rule or a method or a key, and you decrypt it using the same as well. So that when you read it, when you want to read it, you can do that as easily as you encoded it. But don't share your keys to anyone else. Otherwise, they'll also be able to read your messages that you intended to keep it secure. So let's change the tables again and let's see what happens when you make use of KMS. So on the high level, you have the data, that is your plain text data. And with the help of KMS, you can encrypt your data and store it on your AWS S3 or any application that you need, and decrypt it the same way using the methods available in KMS. But this is just the high level. There are a lot of things to be discussed in KMS. I'm just giving you an idea how simple this can be when you're sitting on the top of the mountain. And that's what we'll be discussing today as well. So in general, when we think of security, the hierarchy and the level of protection with respect to the ways we enforce the policies is like, so you have the level 0. So level 0 is no encryption, so plain data, anyone can read it and it's not secure enough. That's like the plain text data that we have. Next, when you add a few more features, you reach to level 1, server-side encryption with server having the keys. So when you want to decrypt the information, the server already has the key. So when you want to retrieve the data, you get it decrypted, and when you save them, you store the encrypted content. Then on to the next level, level 2, server-side encryption with client having the key. So here, the server which is having the protected data cannot encrypt or decrypt the data because the client has the key and not the server. And as the key is also with the client itself, so anyone who wants to use the data that is stored in the server has to have the key that is being used to encrypt the data, which makes it more secure. Then the highest level, I won't say this is the highest level, but according to this chart, let's suppose we are on the level 3 right now. So that is client-side encryption. Here the client which is having the data encrypts the data, and the key is also with the client itself. So you can store and retrieve the encrypted data on the client itself. And when you want to use it, you can decrypt it using the same key that the client has. Other than that, there is no way to access the unprotected data, and sometimes it's protected from the people who have lesser privileges on the client as well. So I hope you got the idea of how the levels of security work. Now let's come back to the type of encryption and why are they important. So the first one is encryption at rest, and the other one is encryption at flight. So you need to understand why these are important, because when you work on the security aspects of the data as an architect, you need to think 100 times as to what are the most feasible ways to implement them. So when you think of data at rest, you should think in terms of the data which is stationary, like it might be stored in your file system or block storage or any data storage that you have which appears to be at rest. So understand the meaning from the concept itself. Like encryption at rest, it means which is stationary, like it might be stored on your file system or block storage or any storage service that you have. And encryption at flight or transit, so you might be already able to relate to this, like taking a flight to travel to one place to another. And similarly, here as well, encryption at flight applies to data that is being sent or which is being traveling from one point to another. So let's suppose I am sending you the data and you are using a form of application that we are interacting with. It's not that I'm sending it on a wire so that you'll collect it at the other end. It is going over the internet, isn't it? So that becomes a data that is in transit, or it is at flight right now. It is going from one point to another. So that type of encryption is called encryption in flight. So encryption in flight. Here you see when we send our data or message over to someone else over another application, the data is protected using the secure communication channel, which in theory cannot be breached in between the starting and the destination. Let's switch to the application based. Here we are using SSL encryption as the data is transmitted and decrypted using the same, making the channel secure to communicate. And that is why it is called encryption at flight. So let's suppose you're using this application, same application, and you are trying to send a message to this application too. So over the internet, it has to be secure. So here we are using SSL encryption for the data or the encryption in flight. So remember, whenever you see a question or concept in AWS which talks about encryption in flight, think about SSL TLS. And when it comes to encryption at rest, if we see the biggest difference here is that the data with user 1 is encrypted. So if it has to send it across to someone else, it can share the encrypted data without having to worry about it being read due to the man in the middle attack. So if you see, the man in the middle right now is John, who wants to read the message, but all he is getting is an encrypted format of the message. The only members who can read that text are the ones who have the key to decrypt it. And that's why, or that's how you secure your data at rest. And having said that, even if someone tried to get access to the data at rest, they won't be able to read it either, because it is already secure until and unless they have the key. So if they have the key, you're done and dusted. But if they don't and you have encrypted your keys, nothing to worry about. So I hope you got the idea of how different encryption at flight and encryption at rest are. So I hope you got an idea of how encryption works and what impact does a key have in the encryption. So I have kept it very simple so that everyone can understand the basics, but don't get carried away as things might get very tricky from here on. So please pay full attention to this. So one thing that I want to clear off at the start is that whenever you hear about encryption keys, encryption in general in AWS, that would be about KMS, and that is our key management service. So having said that, the main objective of using KMS is that it helps you to easily create and control the keys used to encrypt, decrypt, or digitally sign your data. So I know this might be a bit confusing, but just keep in your mind that whenever you want to encrypt your data, and I'm talking about any data that you make use of in AWS, you can more or less use KMS to do that job for you. That is why it's mentioned here that KMS helps to easily create and control the keys used to encrypt or digitally sign your data. Here in KMS, you can create your own cryptographic keys and manage them using the KMS console or CLI and use it across almost all the services that are supported. So I know it's a bit of exaggeration, but you can check the list of supported services in the documentation as well. But the most important thing that makes KMS so secure is that it uses hardware security modules, that is HSM, that has been validated under FIPS 140-2. If you don't know about FIPS 140-2, let me tell you that there are security requirements that a cryptography module must meet, which in other words is a standard that it should meet. And FIPS, or Federal Information Processing Standard 140-2, provides a very high quality of level of security and is being currently superseded by FIPS 140-3. I think AWS will incorporate the new module for this as well in the future. I haven't checked that exactly, so don't worry about that. But if you want, you can read more about it in the documentation. Moving on, when it comes to compliance and auditing, you can as well integrate KMS to CloudTrail so that it can keep track of what is going on in the encryption modules and can alert you on the changes. One more good thing is that if you are making use of AWS free tier, it includes 20,000 free KMS requests each month. That is great, but it solely depends on how badly you are milking the service. And there are a lot of benefits of using KMS, but I have mentioned a few here that might be useful for you. So the first one is centralized key management. So creating your keys and using them is well and good, but how effectively can you manage the keys is really important, isn't it? And with centralized key management, you can control everything about the key using the AWS console or CLI, like key rotation, changing the keys or creating new keys or deleting keys, and scheduling deletion and rotation as well. And that's something that is really good about KMS. The second one is also very important for you as an architect and developer, that is AWS service integration. So as I've already told you and explained to you about encryption and why at rest and at flight encryption is very important, here AWS KMS integrates with a lot of AWS services to encrypt data at rest. And in order to protect your data at rest, integrated AWS services use envelope encryption that we will discuss in a short while, where a data key is used to encrypt the data and is itself encrypted under a CMK, that is a customer master key stored in AWS KMS. There are so many services with which you can integrate KMS that you will be blown away. Just go to the link that I have shared in the description to view the list of supported services. So there will be a lot of them like EC2, EBS, RDS, etc. Like a lot of them. The third one is custom key store. So in KMS, you can have your own custom key store which will be backed by, or you can say you will be using the hardware security module to provide you a level of security that you need. And whatever keys or CMKs actually stored in the custom key store are managed by you like other CMKs and can be used with any AWS service that integrates with AWS KMS. So rather than using AWS default key stores, you can as well create your own custom key stores and you can create your CMKs inside that as well. So I know you might be thinking he's talking a lot about CMK, but what exactly it is? So let's go ahead and check that out. Okay. So as per the definition on AWS Key Management Service or AWS KMS is a managed service that makes it easy for you to create and control customer master keys and in turn the encryption keys as well that is used to encrypt your data. So here I want you to focus on the couple of terms that I have here. So one is managed service, the second one is create and control CMK, and the third one is the encryption keys used to encrypt your data. So AWS provides you with a managed KMS service, so you don't have to worry about the things related to it, if like the service is responding or not, or will it be up or not, what if it does not respond on time, because it will be the headache of AWS and not yours. So don't worry about that. It will be responding as per your needs. So if you go to AWS console, you will see three options to use KMS. So you will see AWS managed keys. So the second one will be the option to create your customer master keys, and the third one, you will be able to create your own custom key store. So you might be thinking, what is AWS managed keys? So let's suppose you are using S3. When you create a bucket, you will get the option to automatically encrypt new objects stored in the bucket. So you can automatically encrypt the new objects that you store in the bucket itself. So you can enable server-side encryption, because S3, whatever you store on S3 will be your server-side encryption. So there will be two options for encryption types. So you can choose either AWS or Amazon S3 key, so that is SSE S3, or AWS Key Management Service keys, so that is SSE-KMS. So if you choose the AWS Key Management Service key, so that is SSE-KMS, you will get three options for the AWS KMS key. So the first option will be you can use your AWS managed keys. So it will give you the ARN, and either you can choose from your KMS master keys that you have, or you can enter the KMS master key ARN as well. So here, if you choose AWS managed keys, S3 will create a key for you and add the ARN to the bucket, so that it will use that particular key. So if you choose KMS master, you can choose from a list of the created CMKs that you have, else you can enter the ARN of the key itself. And this option is available to all the supported services. So all the supported services, in the sense like wherever KMS is supported for the services that AWS provides, you can choose these options. So I hope you got the difference. And when I read this statement again, I think you will be able to get a clear picture. So AWS Key Management Service is a managed service that makes it easy for you to create and control customer master keys, or CMKs, and the encryption keys used to encrypt your data. Now that we talked about CMK, that is customer master key. So when we talk about CMK, it is basically a logical representation of a master key. So when we talk about a master key, you know that a master key is the trump card, which can help you encrypt data, but moreover helps you to secure other keys as well. So like keys for data encryption, encapsulation of keys, or authentication keys as well. And the information of the metadata that CMK has is like you have the key ID that you see, the big key ID that you have here, the creation date, so when the date is of the creation, so for the CMK. The third one is the description. You can add a string for the part of the description that you have, and the key state. So it should be either enabled or disabled. The next, AWS supports the creation of two types of CMKs. So one is asymmetric CMKs, which represents an RSA key pair that is used for encryption and decryption, or signing and verification, and not both. So you can either encrypt and decrypt, or else you can use it for signing and verification, but not both. The second one is symmetric CMKs. Here it represents a 256-bit key that is used for encryption and decryption. And remember, when you hear asymmetric, it means unequal. So that is why you have a key pair here instead of a single key, which is when we use the symmetric keys. So symmetric keys will have a single key, that will be a shared key, but in asymmetric, you will have a key pair. Here I have mentioned three types of CMKs. So we know about customer managed CMKs. Here you create and manage it for the services that you want to use it for. The rotation and schedule deletion, all of this is managed by you. The second one is AWS managed CMKs. So this one, so it gets created during the integration of AWS service. As I mentioned before, that you can integrate a lot of services with a CMK or the AWS KMS. So when you integrate it, it will create a key for you. So that will be your or the CMK for you. So that will be the AWS managed CMK. Few of the services support only AWS CMKs, and few other provide you a choice between CMKs, else you can make use of the third one that we have here, that is the AWS owned CMK. So the third one is AWS owned CMK that we have here. So as the name rightly suggests, it is not created or owned or managed by you. It is managed and owned by AWS itself. And you might think, what would AWS need it for? So that's a very good question. So these are CMKs that an AWS service has as a part of its armory. So the service uses it to protect the resources that are a part of the service, but it's not just restricted to your account. So it can be used for multiple accounts as well. So it can use the CMK for other accounts as well. But there are considerable differences that I have mentioned here for 3 of them. So you can view the metadata of customer master key or CMK and AWS managed CMK, but you cannot for AWS owned CMKs because you don't own it. So you cannot view the metadata. And can you manage CMK? Yes, you can manage the CMK, a customer managed CMK, but not the other 2 because they are AWS managed. So you cannot manage them. So you can only manage the customer managed CMK. Third one, used only in my account. Yes, it's used only in your account if you choose customer master key and AWS managed CMK, but not for AWS owned CMK, as I already told you. And the rotation policy or the automatic rotation policy is also different. So it is optional for customer managed CMK and it rotates for every 365 days or 1 year. And it is mandatory for AWS managed CMK required. So that is required because it is mandatory and it rotates every 1095 days, that is 3 years. And for the AWS owned CMK, it varies from the service to service to which it belongs. So now let's discuss on the differences between symmetric and asymmetric keys. So when you see the asymmetric keys here, so this one, so this actually represents a mathematically related public key and a private key pair that you can use for encryption and decryption or signing and verification, but not both. So if you see this data here that we have, so imagine this to be a text file. So if I want to encrypt it, I'll be using a public key to create the encrypted data and we'll use the private key to decrypt it. So here you will have a pair of keys, one the public and the other one will be private, which you will be using to encrypt and decrypt the data that you have. The other end we have the symmetric keys. Here the symmetric key represents the 256-bit key that is used for encryption and decryption. So if you see here, we have the data and we encrypt it using a secret encryption key and we decrypt it using the same shared key. So that is why it is symmetry, or that is why there is a symmetry here. But having said all this, you may not use CMK to encrypt data. You might use something else to encrypt your data. Confusing, isn't it? Don't get confused here. Let's talk about that. So if you want to encrypt your data, think of data keys. So it's very easy to remember. Data keys are the keys that you use for encrypting your data, including large amount of data and other data encryption keys as well. So you might ask me, how do you create data keys? Yes, of course, you will use the CMK to generate, encrypt and decrypt data keys. But you will make use of it and not use KMS for it. You generate the data key and you can use it outside of KMS to encrypt or decrypt your data. So there are 2 options for you in that as well to create the data key. So one, you can call the generate key data or generate data key operation, which generates the key with the plain text data key. And you have other option, that is generate data key without plain text. This one will generate it without the plain text data key operation. So here if you see, we have the CMK and the encryption algorithm, and based on what operation do you choose between these two, generate data key and generate data key without plain text, you can generate the data key without plain text, else it will give you the plain text version of the data key as well. So either you can generate both of them using generate data key, or else you can generate only this one by using generate key without plain text. So that is the plain text version of the data key that you have, or the encrypted data key that you have here. So once you have created your CMK, you can use that. As you can see in the definition, you can use the key ID to pass the CMK, as you can see here, to create your data key and use it for your security. So now let's see how the encryption and decryption works using the data keys. So let's see this very carefully. So let the data object that you see here is a string. So imagine that you're using a Python library like Boto3 to encrypt this file. So what you do is you create the data key and encrypt the file to generate the ciphertext. So either you can actually use the encrypted data key to generate the plain data key and then use the encryption algorithm to generate the encrypted format of the data object that you have, that is basically your ciphertext. So now your encryption is done. So you have generated the plain text data key using the encrypted data key that we have here, and with that we have generated the ciphertext. So that is your encryption part. So the best practice is, once you have actually encrypted your data, you have to just delete the plain text data key so that you don't have security issues. But when it comes to decryption, you have to pass the encrypted data key that you have generated using the data key by using the CMK, you have to pass it back to the CMK. Using the decryption algorithm, it will generate the plain text data key again, and using which you can decrypt the data object once again. So the encryption works like you have the data object here, you have the plain text data key and the encryption algorithm, using which you create the ciphertext, which is basically your encrypted data. And when you have to decrypt that, you have to again make use of the encrypted data key, pass it to the customer master key, and it will use a decryption algorithm to generate the plain text data key again for you. And using this plain text data key, you can decrypt the object that you have. So I hope you are getting the cycle here. So if there are any further confusions, then you can just type them in the comment section below so that I can help you out with that. Okay, now it's time for the data key pairs. So data key pairs are asymmetric data keys that consist of a mathematically related public key and private key. So the asymmetric keys are designed to be used for client-side encryption and decryption or signing and verification outside of AWS KMS. So here as well, there are two operations available to you to create the data key pairs. So the first operation is generate data key pair, which returns a plain text public key, a plain text private key, and an encrypted private key. So the three things that you get here is public key, plain text private key, and encrypted private key. And the next operation that you have here is generate data key pair without plain text, which returns a plain text public key and an encrypted private key, but not the plain text private key that you have here. So you can make use of your CMK to create the above mentioned three things or just two things without the plain text private key based on the operation that you choose. So I hope that is clear. So if we see the request here, so the request that you have here, so you pass the key ID, that is your CMK, and you pass a key pair spec or specification that can be like your RSA 2048, RSA 3072 or RSA 4096 based on your requirement. So you will get the key ID, the key pair spec, the private key ciphertext blob, the private key plain text, and the public key. So now let's talk about how does the encryption and decryption work in data key pairs. So for encryption, we make use of the public key to encrypt the data that you have and create the ciphertext. So you have the data object, you have the public key, you use the encryption algorithm to create the ciphertext. And to decrypt the same, you need the encrypted data key or the encrypted data private key that you have, and you generate the plain text private key again, and then using the decryption algorithm, you decrypt the object that you have here. So to reiterate this once again, to encrypt, we make use of the public key to encrypt the data that you have and create the ciphertext, that is basically your output data. And to decrypt the same, you need the encryption data key to create the plain private key, and then using that we decrypt the encrypted data that we have and we get the output that we want. So here if you see, we are not using the same keys again and again. We are using a public key to encrypt the data and the private key to decrypt that data. That is why it is called asymmetric data encryption, and that is done by using data key pairs. So if I use data keys, it is for symmetric data encryption, and if I talk about data key pairs, it will be about asymmetric data encryption. And now if I show you this and ask you, did you understand anything from this again? So I'll wait for you to see this once again. No worries, no hurries. You can pause it as well and try to recap or try to understand what exactly went here, because we are currently discussing asymmetric keys and symmetric keys, and I want you to be thoroughly clear with that. So now let's recap this once again. In asymmetric keys, first thing is that you use asymmetric keys, you need to create data key pairs using the CMK. So once you create the CMK, you can generate the data key pairs, and with that, what do? We get the public key, the plain text private key, the encrypted private key. Using the public key, we encrypt the data that we have, and using the private key, we decrypt it. We make use of the key pair here, not a single key. I hope you got the point. Now moving on to the symmetric key, here we make use of the CMK to create the data key, and which gives us the encrypted data key to create the plain text key, using which we encrypt the data, and then we make use of the same to decrypt it. So here we make use of the shared key and not a key pair. That is why it is called a symmetry, or it is called symmetric keys. As we already discussed that using data key pairs, we can encrypt and decrypt the data. And there was one other thing that we missed out. So which was signing and verification outside of AWS KMS. So now if I ask you, when I give you a document and I ask you to sign, what is the purpose of that? Any ideas? So a signature that you put on a document ensures that I have a proof that it's you who has signed it. And if I have to validate it, I'll try and match the signature that I have of yours with the signature on the document. Same way, a digital signature is a mathematical scheme for verifying the authenticity of the digital message or document. Let's see the example here. So if I want to sign a message, we have to create the message digest. So this one, which is basically a hash function. So we have the message digest here, and we take the plain text private key and the signing algorithm that we have to get the signature of the document, which is basically your required output. So now once you have the signature, you need to validate that. So your signing is done. So signing means you have created the signature for your data that you want. And then now once you have the signature, you have to validate it as well, because that is what we want, isn't it? You put the signature, you have to verify it, or you have to validate it. So here you have to reverse engineer. And in this phase where we did the signing, we created a message digest, and then we formed a signature out of it using the plain text private key. So in verification, we'll take the public key to decrypt the signature to match the message digest, that is the hash value. So for both the places, for the verifications to be true, the hash values for the message digest, that is a message digest, have to be same. So that is when it will tell you that, yeah, it is true. If the hash values are different, it will reject it and it will tell you that it is a false case. And when we talk about alias, rather than using the long multi-digit number with hyphens, you can actually provide a name of your choice and have it as your alias for your CMK. So that's a very good thing for us, because who wants to remember all these things? You can put it a name there and you can use it. Let's move on. So just to clear the things once again, when we have to sign using the data key pair, you have the data, you create the message digest using the hash function, and we use the private key or the plain text private key to create the signature. And when we have to verify that, we take the signature using the public key to decrypt the signature to match the message digest, that is the hash value. So both the places, the hash values have to match. So if they do match, then it is true, else it will be false. One more very important concept that CMK helps us is to create envelope encryption. So we saw how we can encrypt the data, but what about the keys? They should also be protected, isn't it? So for that, what we can do is we can encrypt the plain text data key with the data key, as we know, that's fine. We can encrypt that. And then what we can do is we can encrypt the data key under another key. And that is what is called as envelope encryption. So you take the data key and encrypt it under another key. So that is what is called as envelope encryption. So envelope encryption is the practice of encrypting plain text data key with a data key and then encrypting the data key itself under another key. But what if you encrypt the data key, and then how are we going to decrypt the data? So for that, we need to have a top level plain text key that will act as our master key. I know it's a bit confusing, but remember one thing here. So you create CMK using KMS, that is clear, isn't it? So you create CMK using KMS. So if you have to encrypt the data, you need to create data key using CMK, which you have created just now. So that is also clear. Next, you need to remember that when you create the data key, you will get an encrypted data key and a plain text data key. And the master key that I explained above, which is our top level plain text key, that will act as our master key and can be stored in KMS, and that is called the customer master key. So you need to think in a way that you are storing the plain text key encryption in the form of the master key inside KMS, so that you can encrypt and decrypt your data encryption keys. This is something, or this is one of the best features that I feel about KMS. So it gives you the flexibility to take a key that you have, make it a master, and then use that key as your master key or customer master key to encrypt or to create the data keys for sure, and then to encrypt your data. And that is one of the best things that I feel. So as we can see here, we take the master key that we have, we encrypt the data key, we create the data encryption key. So that is the encrypted data key. And similarly, what we have doing it here is like when we have this CMK or the customer master key, we actually use it to encrypt the data key and make a data encryption key out of it. So that is called envelope encryption. So you can do that as well. So now let's move on to the concept that is being heavily discussed as well, that is key rotation. And we need to understand first what is key rotation. So I hope all have seen the current India versus England series, where the England team actually has a player rotation policy, which apparently hasn't been working off late, but that's good for us, isn't it? In that, what they do is they rest a few players for a match and then use new players in the other matches, so that in a way they rotate the players to keep them fresh. That's the whole idea. How long it works, I don't know, but yeah, it may be good in the future, but that's debatable. So now imagine the same for your custom master keys, like your players. As per the cryptography standards and practices, it is discouraged to extensively reuse the encryption keys. So what we can do with that? So we need to rotate the use of CMK as well for our encryption, because if you keep using the same keys again and again, you risk exposing the keys to the attackers. So if someone is trying to find out the CMK fingerprint and trying that for a long amount of time or for a large amount of time, it'll take a bit of time, but there could be a human error that could expose the data and will make it vulnerable. But I'm not sure that would happen, but yes, it's quite vulnerable that way. So it is always recommended to rotate your keys. Think of it as using the same password for a long period of time. When you consider security best practices, they would recommend you to change it every 1 or 2 months, isn't it? So in the same way, so it is highly recommended to rotate your CMKs. So here also there are two ways to do this. Either you can create a new CMK and change the alias of the CMK for all the applications using it, or enable automatic rotation of the keys. But the interesting thing that we see here is that every CMK has its cryptographic material. So you can think of that as a metadata of the key. Don't try to overanalyze this. So a particular CMK will have its own material that actually comprises or makes the CMK. So when you enable automatic rotation, you can actually change the cryptographic material of the key rather than creating a new CMK. So you can change the masala inside the CMK, but that whole CMK will remain the same logically. So in that way, you can change the composition of the key. I said masala, but that's composition. I'm sorry for that, but not the key itself. And the benefit of it is that it preserves the previous material forever, so that you can make use of it to decrypt data using which it was encrypted, and the material only gets deleted when you delete the CMK. So you're sorted that way, isn't it? So if you see here, so now if you see the visual here, the backing key is the cryptographic material. So the composition or masala that I told you, the backing key, that is the thing that gets changed, and also the thing that gets used for encryption. So if you have this key here, so this key that you have here, we have the CMK ID and the backing key. And when we enable rotation or the key rotation, the backing key here actually changes. But the previous backing key gets protected so that we can make use of it to decrypt data using which it was encrypted. Okay, so based on which backing data it was used for encryption, we can use the saved backing keys to actually decrypt the data again. So we are not going to lose any data that we have here. And the backing key only gets deleted when you delete the CMK. And the CMK ID actually remains intact. And that's the only logical difference that it brings, nothing more. And you can enable rotation of keys using the AWS console, AWS CLI API. And when you enable automatic key rotation, AWS KMS rotates the CMK 365 days after the enable date and every 365 days thereafter. And if you see the way we can enable and disable key rotation using the AWS KMS API, so to enable, we can use AWS KMS enable key rotation operation here and pass the key ID. And if we have to disable it, we can use AWS KMS disable key rotation. And if we want to get the status of the key rotation, we can just use the operation that is AWS KMS get key rotation status. So it will give us the key rotation enabled status, whether it is true or false. And remember that it will take the parameter as --key -id, where you have to pass the key ID, or you can use the alias as well, that I'm sure. If we can check the API status as well. But why should we do this key rotation? There must be some benefit, isn't it? as what I already told you, but other than that, there will be key differences or key benefits to this. So the first one is that the properties of the CMK, including its key ID, key ARN, region, policies, and permissions, do not change when the key is rotated. So we are very much secure about using the CMK again and again, but we have rotated it, so it's much more secure now. And you do not need to change applications or alias that refer to the same CMK ID or ARN, because the ID does not change and the ARN also does not change. So your applications are not at all affected. After you enable key rotation, the AWS KMS actually rotates the CMK automatically every year. You don't need to remember or schedule the update because everything here is automated. But on the other hand, there is one more demerit here. So you need to pay the extra money to keep your key rotation going on. So you need to pay for that. So that's something that you have to do, because you can't expect everything to be done for free, isn't it? So you have to pay AWS for some things. We have been paying a lot, I guess. Yeah. Now that we have discussed automatic key rotation, let's talk about how does manual rotation work. I told you about the two ways we can do this. So this is the second way. So here you have to create a new CMK and use it in the place of the current CMK instead of enabling automatic key rotation. So when you are trying to make use of manual key rotation, you are actually creating a new CMK. And you know what? I prefer manual key rotation as well, because it gives me the flexibility over the rotation and the scheduling and the cost as well. And if you are using asymmetric CMKs or CMKs in custom key stores or CMKs with imported key material, you can control the rotation if done manually. Otherwise, you will not be able to do that. So here we have the application which has a provision to rotate the key manually. So the application creates a new CMK with the new CMK ID that we have here, and the backing key also is new. So you might ask me, what happens to the already existing encrypted data? So for this, AWS recommends that you keep the old CMK enabled so that you can decrypt your data, as AWS KMS detects which CMK was used to encrypt the data, and it uses the same one to decrypt. It is just so smart, isn't it? So in order to make use of the new CMK, you can use the update alias operation to update the CMK of the existing alias so that you can make use of the new CMK ARN and ID, and you will have the alias that you can point it to so that your applications won't be affected even if you have created a new CMK. So that's one more benefit, isn't it? Because when you create a new CMK, alias ARN and target key ID change as well. So but that does not affect because we have the alias, so that we can actually update the alias to this one, and we can actually enable that or disable it depending on our usage, and we can keep using the new CMK. So we have discussed what is a CMK, how it works, how do symmetric and asymmetric key works, how does the rotation work. Now let's talk about how encryption works for S3 and how KMS is being used there. So now let's start off with server-side encryption. So server-side encryption is the encryption of data at its destination by the application or the service that receives it. So it's like keeping your data secure after transit or at the server side. So the first one we need to discuss is server-side encryption with AWS S3 managed keys or SSE-S3. So when you use server-side encryption with Amazon S3 managed keys or SSE-S3, each object is encrypted with a unique key. So for extra security here, S3 actually encrypts the key itself with a master key that it regularly rotates. Rotate means it changes periodically, and using that master key, it again encrypts the unique key as well. And when it comes to encryption, it uses 256 Advanced Encryption Standards AES 256 to encrypt your data. The most important thing here is you must include XAMZ server-side encryption header to request server-side encryption. But you can enable that in the console as well that I told you. So I hope you got the gist of it. Let's move on. And the second one is server-side encryption, that is server-side encryption with customer master keys stored in AWS Key Management Service. So that is one thing that we are delighted to hear about, isn't it? Because we have just now discussed how KMS works. So when you use server-side encryption with AWS KMS or SSE-KMS, you can use the default AWS managed CMK, or you can specify a customer managed CMK that you already created. But don't worry, if you do not specify a customer managed CMK, S3 automatically creates an AWS managed CMK in your AWS account. And if you want to use a customer managed CMK for SSE-KMS. You can create the CMK before you configure SSE-KMS. So what happens here is you have the object. When you send it to AWS S3, every object is encrypted using the AWS managed KMS, and that gets stored as an encrypted object on the S3 itself. And here there are a few points that have been mentioned. So AWS KMS encrypts only the object data. Any object metadata is not encrypted, and you should always include S3:X-AMZ server-side encryption :AWS KMS or the ARN that you have. And when you upload an object, you can specify the AWS KMS CMK using the AWS AMZ server-side encryption -AWS KMS key ID header. So key ID will basically be your CMK ID. So that you can pass it as a header. And the third one is server-side encryption with customer provided keys, or SSE-C. So with server-side encryption with customer provided keys, or SSE-C, you manage the encryption keys and Amazon S3 manages the encryption. So that's the difference here with the above two, as you are in charge of managing the encryption keys and AWS manages the encryption. AWS writes to disks using the encrypted data key that you have and decrypts using the same key when you access your object. So once again, server-side encryption with customer provided encryption allows you to set your own encryption keys. So if you think AWS stores it, it does not. Amazon S3 does not store the encryption key you provide. Instead, it stores a randomly salted HMAC value of the encryption key to validate the future requests. If you aren't sure about HMAC, you need to remember that HMAC, or hash message authentication code, is a computed signature which you might send along with the data or the portion of the data, and this will help you to authenticate that the data has not been altered or replaced. So if you see here, we have the client and it has the client managed data key, and we send it along with the object, and it basically encrypts it and stores it as a part of the encrypted object. Now let's talk about the client-side encryption using service S3. So we have discussed enough about client-side encryption. Having said that, client-side encryption, as we know, is the act of encrypting data before sending it to Amazon S3. So the protection that you provide is for the data at rest or before storing it in S3. But to enable client-side encryption, you have to give the following options. So you use a customer master key stored in AWS Key Management Service. You use a master key that you store within your application. So now see the diagram and imagine the data that you have is at the client side that you have here. And if you want to encrypt it before storing it on S3, so you'll need a key to encrypt and a key to decrypt, isn't it? So let's see how the encryption works here. So this is the encryption part that we'll be discussing. So you have the object here. It can be a text file or a log file. So we create a randomly generated plain text data key using the data key generated using the CMK, which is then used to encrypt the object data. That is part 1. So this is the part 1. So the second part will be where, along with the encrypted data that we have here, we need to provide the encrypted data key so that it can be decrypted. At this point, the encrypted data key and the encrypted data object is sent from the client to the S3 for storage. S3 then takes the encrypted data key and associates it with the encrypted object and stores both in S3. So this is something that S3 stores. So encrypted data and the encrypted data key. So now that we have looked at the encryption, now let's see how the decryption works. So just like in encryption, we sent the encrypted data key and the encrypted object to S3. When we make the request for the object from the S3, so here is where we actually make the request data object to be downloaded. So if we make a request, what do we get from there? Yes, we will get the encrypted data key. Here you must ask yourself, what do we do with the encrypted data key? So look at the first half here. Look at the first half of the image here. So we take the customer master key, the encrypted data key, and we generate the plain text data key. Okay. And the second part that we have here. So once you get the plain text data key, what you do? You take the encrypted data using the encryption algorithm. You generate the data object. And that is where you get the plain text data key and the object that you wanted. And that's encryption and decryption for you. But sorry for that, you have to wait a short while for the demo because that will also take a lot of time for us because I'll be covering a lot of aspects in that. and we'll do a wholesome demo there. So please make sure that you wait for that, and the demo is going to be really exciting because we'll be encrypting and decrypting objects using Python's Bodo 3 library, and that is what we'll be doing next. So keep refreshing the documents and the video that you have here for AWS KMS, and try to gather all the doubts and queries that you have and put them in the comment section below, and wait for the demo to come out, which will be coming out very shortly. And if you haven't subscribed already, please do subscribe to the channel. It really helps the channel grow. Please comment on what you liked, what you didn't. Please like the video because it really makes me very happy and it really motivates me. And if you want to be friends, follow me on Instagram at @tougherapollo. And if you want to support me, the links for Instamojo, PayPal and Patreon are in the description as well. So I'll meet you next time with yet another episode of AWS. Until then, it's Pythoholic signing off.